Our universe is vast, seemingly infinite, a breathtaking tapestry of stars, galaxies, and mysteries. But what if this immense cosmos is just one among many? Welcome to the concept of the multiverse, the idea that our universe is not alone, but part of a much grander, more complex collection of parallel worlds. Once the realm of science fiction, the multiverse is now a serious hypothesis, born from the deepest and most puzzling questions of modern physics. Our journey begins not in the vastness of space, but in the bizarre world of the infinitesimally small, the realm of quantum mechanics. At the quantum level, particles don't behave like solid objects. They exist as waves of probability, capable of being in multiple places at once. This quantum uncertainty has led to one of the most astonishing theories, the many worlds interpretation. Proposed by physicist Hugh Everett III, this theory suggests that every quantum event with multiple possible outcomes causes the universe to split. Every choice you make, every coin toss, every random decay of an atom creates new universes where each outcome becomes real. In this view, there exists a universe where you took that job you turned down, a universe where you caught that train you missed, an infinite number of yous living out every possibility. This theory elegantly solves the famous Schrödinger's cat paradox. The cat isn't both alive and dead. The universe splits. In one, it lives. In another, it dies. Both are equally real. But the evidence for a multiverse doesn't just come from the small, it also comes from the very beginning of our own universe. We know our universe began with the Big Bang, a moment of incredible expansion. The theory that describes this is called cosmic inflation. Inflation theory suggests that in the first fraction of a second, the universe expanded faster than the speed of light, smoothing it out and seeding the structures we see today. Some physicists like Alan Guth and Andre Linde proposed a model called eternal inflation. They suggest that inflation never completely stopped. It continues in the vast fabric of space-time. In this scenario, our universe is just one bubble that pinched off from this eternally inflating background. Other bubbles are constantly forming, creating a multiverse of pocket universes. These other universes might not be hospitable. They could have entirely different laws of physics, different fundamental constants, making them sterile and devoid of life. This bubble universe model offers a potential explanation for why our own universe's constants are so finely tuned for life. With infinite universes, it's not surprising that at least one, ours, would have the right conditions by chance. A third, and perhaps the most exotic vision of the multiverse, comes from a candidate for the theory of everything: string theory. String theory requires the existence of extra dimensions beyond our familiar three of space and one of time. In this framework, our entire universe could be a three-dimensional membrane, or brain. The theory allows for other brains to exist floating parallel to ours in this higher dimensional space. A true parallel universe, possibly only millimeters away, but inaccessible through our dimensions. It's even been theorized that a collision between two such brains could have been the event that triggered our own Big Bang. Scientists are actively looking for evidence of such an ancient collision, searching for bruises or anomalies in the leftover radiation from the Big Bang, a potential sign of another universe touching ours. Then there is perhaps the simplest, yet most profound type of multiverse. It requires no new physics, only the assumption that space is infinite. The universe we can see is limited by the speed of light since the Big Bang, but there's no reason to believe space itself ends there. It likely goes on forever. In an infinite space, the possible arrangements of particles are finite. This means that eventually the exact arrangement of particles that makes up our world, our solar system, and even you, must repeat. Far, far beyond what we can see, there is another Earth and another you. This is the quilted multiverse, an endless tapestry where every possible configuration exists somewhere. In this multiverse, there isn't another you that's the outcome of a different choice. It is an identical copy, a doppelganger, living a life identical to yours up to this very moment, simply because in an infinite space, all patterns must repeat. Our observable universe is just one patch in this infinite cosmic quilt. A humbling thought that here is not unique. The final and most abstract type of multiverse is the mathematical universe. Championed by physicist Max Tegmark, it's a radical and mind-bending idea. It posits that our physical world is not just described by mathematics, it is a mathematical structure. The theory goes further, suggesting that any self-consistent, computable mathematical structure corresponds to a physically real universe. Universes with different spacetimes, different particles, and physical laws so alien they would be incomprehensible to us. If it's mathematically sound, it exists somewhere. These are the leading multiverse theories, each born from a different branch of physics, but all pointing towards a similar, shocking conclusion. Our reality is vastly larger than we ever imagined. But what are the implications of this? If every possibility is real, what does that mean for our sense of identity and free will? If there are infinite versions of you, what makes you the real one? The answer from many worlds is that you are all equally real. You are simply the sum of the choices and quantum events that have occurred along your specific timeline, your branch of reality. It's a profound thought. Every failure you've experienced is a success in another universe. Every mistake you've made was avoided by another version of you. This brings us to the biggest scientific challenge: testability. Science relies on evidence and experiments. How can we possibly test for a universe we can't see, touch, or interact with? Some scientists are looking for indirect evidence. For example, some string theory models predict that brain-world interactions could produce specific energy signatures at particle colliders. Others continue to scan the cosmic microwave background, the echo of the Big Bang, for signs of collisions with other bubble universes. For now, the multiverse remains a philosophical and theoretical frontier as much as a scientific one. It pushes the very definition of what is knowable. Critics argue that the multiverse violates Occam's razor, the principle that the simplest explanation is usually the best. A single universe seems simpler than an infinite number. Proponents, however, counter that their theories are simple. The multiverse isn't an added feature, it's an unavoidable consequence of theories like quantum mechanics and inflation. Adding a rule to delete all other universes would be more complicated. Regardless of its ultimate reality, the multiverse concept forces us to reconsider our place in the cosmos. It suggests our life, our planet, our entire universe might be one of a kind on its own terms, but simultaneously one of an infinite number, both infinitely precious and infinitely common. It blurs the line between consciousness, choice, and the physical branching of reality itself. Perhaps the human imagination, with its ability to conceive of endless possibilities, is a natural reflection of a reality where those possibilities truly exist. We stand on the shore of a cosmic ocean, and the idea of the multiverse suggests this ocean is infinitely larger than we can see, with countless other shores just like our own. The quantum realm showed us that reality is uncertain. Cosmology showed us that our beginning may not have been unique. String theory suggested that other worlds might be closer than we think, hidden in dimensions beyond our perception. And simple logic suggests that in an infinite space, everything that can happen must happen. For now, we do not know which door leads to the ultimate truth. The evidence is not yet in. But the history of science is a history of expanding horizons. We once thought the Earth was the center of everything, then the Sunday, then our galaxy. At every step, our cosmic address has become less and less special, and the universe far grander than we imagined. The multiverse may simply be the next, and perhaps final, step in that intellectual journey. The quest for answers continues. New telescopes, new experiments, and new generations of physicists will tackle these questions. Every choice you make creates a story. The many worlds theory suggests that the universe tells all possible stories. Your life is the narrative you experience on one specific branch, a unique journey through an infinite garden of forking paths. The fine-tuning problem remains one of the strongest philosophical arguments for the multiverse. Why are the laws of physics in our universe so perfect for life? The multiverse answers this with the anthropic principle. With an infinite number of universes, or lottery tickets, it's inevitable that one would have the winning numbers for life. And of course, we would find ourselves living in that successful one. String theory's multiverse isn't just a possibility, it's a prediction. The equations that describe strings vibrating to form particles naturally lead to scenarios with multiple branes and dimensions. While direct travel between these brane worlds seems impossible, gravity might be an exception. Some have speculated that gravity is a force that can leak across the dimensions from one brane to another. This leaking gravity could even provide an exotic explanation for the mysteries of dark matter and dark energy, the unseen forces that dominate our cosmos. Let's reconsider the quilted multiverse. It's built on two simple assumptions. The universe is infinite, and the laws of physics are the same everywhere. Within an infinite space, a region the size of our observable universe, a Hubble volume, is just one patch. Given enough space, an identical patch, down to the last atom, is a statistical certainty. This means that right now, there is a person identical to you, in a room identical to this one, watching a documentary identical to this one. An unnerving thought about the nature of individuality. And in the ultimate multiverse, the mathematical universe, even the laws of physics are just variables in an endless set of equations. This theory blurs the lines between reality, mathematics, and computation, suggesting any world that can be simulated can exist. This naturally leads to the question, can we travel between these universes? For now, the answer from physics is a resounding no. In the many worlds interpretation, the split is permanent. The different branches of reality decohere, meaning they can no longer interact. The wave functions have split for good. In the bubble universe model, travel is even less likely. The space between the universes is still inflating at unimaginable speeds, creating an uncrossable gulf. Concepts like wormholes are purely theoretical, and even if they could exist, there is no evidence they could connect to alternate realities, only different points in our own space-time. So, our exploration of the multiverse will not be with spaceships, but with telescopes, particle accelerators, and the power of mathematics and human thought. So, where does this leave us? Is our fate predetermined, with every choice we make simply revealing which pre-existing path we were always on? Or is reality being created at every moment of quantum uncertainty, with our consciousness navigating one path through this ever-branching maze? The questions raised by the multiverse are as much about consciousness as they are about cosmology. It's important to remember that these are not competing theories in a conventional sense. It's possible that multiple types of multiverses exist simultaneously. Our quantum many worlds could be playing out inside one bubble universe, which in turn could be one of an infinite number in a quilted multiverse. The levels of reality could be nested infinitely deep. For many scientists, the beauty of the multiverse is not in finding proof of another you, but in its potential to explain the fundamental nature of our own reality. It could help explain why particles have the mass they do, or why gravity is so much weaker than the other fundamental forces. It's not just a fanciful idea, it is a working tool, a conceptual framework that helps physicists push the boundaries of knowledge. Since the dawn of humanity, we have looked up at the sky and wondered, are we alone? Traditionally, this question meant, is there other life in our universe? The multiverse rephrases the question. It asks, is our universe alone? It raises the possibility that our entire collective story, all of human history, art, and science, is but a single word on a single page in an infinite library of cosmic stories. and it provides a potential, if unsettling, answer to the ultimate why. Why is there something rather than nothing? In some models, universes can spring forth from nothing, a quantum fluctuation in a pre-existing void. If it can happen once, in an eternal system, it can happen infinitely. The multiverse suggests that something is the natural state of things. The existence of our universe, with its perfect laws, required no miracle, only the quiet ticking of cosmic probability on a grand scale. We've journeyed through the many worlds born of quantum choice, the bubble universes of eternal inflation, the higher dimensional brain worlds of string theory, and the endless repeat of the quilted multiverse. These ideas stretch the limits of our imagination and challenge our most basic intuitions about reality. They are the products of rigorous mathematics and brilliant minds grappling with the deepest paradoxes of the universe. Whether any of these theories will one day be proven correct remains unknown. That discovery may be decades or even centuries away. We are, in a sense, the mapmakers of a new reality, and our charts are still mostly blank space filled with theories and tantalizing possibilities. The potential existence of other worlds does not diminish the value of our own. It reminds us that our shared experience on this one timeline, in this one universe, is a precious and unique thing to be cherished. It's a message of who we are on our branch of the cosmic tree, a story worth telling, even in an infinite library. The quest to understand our place in the cosmos has led us to a staggering possibility. Not just a place in one universe, but a single story in an infinite cosmic library. The final frontier may not be out there, but in the very nature of reality itself. Let's explore one of the most disturbing thought experiments to arise from the many worlds interpretation: quantum suicide. Imagine a device linked to a quantum particle. If the particle's spin is measured as up, the device does nothing. You survive. But if the spin is down, it triggers a weapon that kills you instantly. In a single universe model, you have a 50% chance of dying. But in the many worlds view, your consciousness can only continue in a timeline where you are alive to experience it. From your perspective, you will press the button 1,000 times, 1,000,000 times, and you will always survive. You become immortal. To an outside observer, you died on the first flip of the coin. But from your point of view, you are trapped in an endless series of improbable survivals, proving the multiverse's existence only to a self that can never report its findings. The mysteries of the multiverse may also be intertwined with the universe's most powerful and enigmatic objects: black holes. According to general relativity, anything that crosses the event horizon of a black hole, its point of no return, is lost forever. This includes the information that makes up that object. However, a fundamental law of quantum mechanics states that information can never truly be destroyed. This contradiction is known as the black hole information paradox. Stephen Hawking proposed that black holes are not truly black. They slowly evaporate over trillions of years by emitting what is now known as Hawking radiation. But this radiation seemed random, carrying no information about what fell inside. So, where did the information go? Some physicists proposed a radical idea. What if a black hole is a one-way door to another universe? That the information isn't destroyed, but ejected into a newborn cosmos, creating a new bubble in the multiverse foam. A more recent and equally startling idea is the holographic principle. It suggests that all the information of a 3D volume, like our universe, can be encoded on a 2D surface at its boundary. This would mean that our three-dimensional reality might be a holographic projection of physical processes happening on a distant, two-dimensional cosmic horizon. This brings us to another speculative but popular concept related to multiple realities: the simulation hypothesis. This is the idea that our entire universe, including ourselves, is a highly advanced computer simulation created by a more advanced intelligence. If a civilization could create one such simulation, it could create thousands or millions. A simulated multiverse, with each universe running as a separate instance, perhaps with slightly different parameters. Proponents suggest we could look for evidence of this, like glitches in the laws of physics, or finding that space-time itself is pixelated, made of discrete units at the smallest possible scale. While unfalsifiable today, the simulation hypothesis serves as a modern allegory for the deeper question: is our reality the fundamental reality, or is it nested within something else? This brings up a critical and often overlooked challenge for all infinite multiverse theories: the measure problem. In an infinite space where everything that can happen happens an infinite number of times, how do you calculate probability? Saying an event is likely becomes meaningless. Physicists are struggling with this measure of infinity. Without solving it, the multiverse risks being a theory that predicts everything and therefore nothing at all. An alternative to an infinite, simultaneous multiverse is a sequential one: the cyclic universe model. In this model, the universe undergoes endless cycles of birth, death, and rebirth. Each new universe could be considered a parallel world in time, not space. Each cycle could reset the laws of physics, trying out new combinations, until one, like ours, is stable and life-bearing, a multiverse unfolding through time itself. However, current observations of dark energy suggest our universe's expansion is accelerating. It will likely not end in a big crunch, but a cold, empty, big freeze. This makes a simple cyclic model unlikely, but it does not rule out other, more complex versions, such as those driven by brain collisions. The concept of the multiverse has profoundly captured the human imagination, becoming a staple of our modern mythology. It speaks to our deep-seated curiosity about the roads not taken, the what-ifs of our own lives. Storytellers use it as the ultimate canvas for exploring choice, consequence, and identity. In fiction, we can do what physics forbids. We can cross the streams of reality. This cultural fascination serves a purpose. It popularizes complex scientific ideas and encourages the public to ask the same profound questions that physicists do. But how do we bridge the gap between imagination and proof? What does the real, tangible search for the multiverse look like? One avenue is cosmology. By creating ever more precise maps of the CMB, we look for anomalies like strange cold spots or repeating patterns that could be the gravitational imprint of another universe bumping into ours. Future experiments will search for specific types of polarization in this light, patterns that could confirm cosmic inflation, the theory that provides the fertile ground for bubble universes to grow. Another avenue is particle physics. Some theories of the multiverse, especially those based on string theory, predict the existence of extra dimensions. If these dimensions are large enough, high-energy collisions could create particles that get kicked into these other dimensions, showing up in our detectors as missing energy or momentum. The next generation of particle colliders will push energies to new frontiers, giving us a clearer window to either find evidence of these dimensions or rule out the theories that predict them. A third, more speculative tool is the study of gravitational waves. These ripples in space-time could carry clues from the earliest moments of creation. If other universes are close by in a higher dimension, powerful cosmic events, they might send faint gravitational tremors into our world, an echo from another reality. But perhaps the most powerful tool of all remains the human mind. The multiverse wasn't discovered by a telescope. It was inferred from the logic of our best-tested theories. The next great leap forward may not come from data, but from a new idea, a new mathematical insight that ties all these disparate threads together. As we wait for physical proof, let us consider the personal impact. If all outcomes happen, does that diminish the weight of our choices? Some might argue that if a version of you will inevitably make the wrong choice, it absolves you of responsibility. But physics doesn't suggest that. You are responsible for the actions of your branch. The happiness or suffering that exists on your timeline is the direct result of the path you navigate. Your choices define the reality you experience. In a grander sense, the multiverse may even reinforce the importance of morality. In the infinite game of reality, cooperative and ethical strategies might simply be more successful and create more stable, conscious worlds. It's easy to get lost in the infinite, to feel small and insignificant. But the multiverse concept can also lead to the opposite conclusion. It suggests that simple acts of kindness, love, and creativity are not isolated events. They are fundamental patterns that resonate across countless realities. Every piece of art created, every problem solved, every moment of compassion enriches not just our world, but the very fabric of possibility. For a brief moment in cosmic history, on this small branch of reality, the universe has become self-aware through us. We are the part of the cosmos that can wonder about the whole, a conscious piece of the multiverse trying to understand itself. That is not insignificant, it is a miracle. The story of our universe is still being written. The many worlds interpretation suggests it is not a single book, but a library, with a new page written every instant for every quantum event. We have explored the quantum splittings of Hugh Everett, the eternal inflation of Alan Guth, the extra dimensions of string theory, the statistical certainty of an infinite cosmos, and the ultimate abstraction of a mathematical reality. These are not mutually exclusive. They might all be different facets of one, even grander, unified truth about the nature of existence. The search requires patience, collaboration, and a willingness to embrace ideas that shatter our perception of the normal. Because in science, the most exciting discovery is often the one that tells us we were wrong, opening the door to a reality stranger and more wonderful than we could have ever imagined. So, is our universe all there is? The final answer awaits. But the question itself has changed us. It has forced us to confront the boundaries of our knowledge and the foundations of our reality. It has shown us that even our grandest concepts of everything might be hopelessly provincial. And it has given us a new sense of humility and of wonder. We live on one planet, in one galaxy, perhaps in one universe among a sea of countless others. Perhaps the final truth is unknowable, or perhaps it is waiting just beyond the reach of our current instruments, hiding in the fabric of space-time itself. But the journey of discovery will continue, because curiosity is the fundamental constant of our particular corner of the multiverse. And as long as we exist, we will never stop asking, what else is out there?